Hi, this is just going to be an optional recap of the last part. I saw in the comments a couple of people had trouble following it towards the end and didn't know why we were doing what we're doing. So if you understood the last part, you don't need to watch this. It's not going to have anything new in it. I'm just going to go back over what we did. And actually I changed my mind a few times about what I was doing. So we'll recap what the actual code we ended up with means and what it does. So the thing we did was we added player death. The player explodes into shards and those shards reassemble. And so the first part is in the player step event, and that was a thing we added to the bottom. We eventually decided it should have been at the bottom. And the code says, create a variable called enemy touching me. Look for an enemy that's touching me. Instance place means, is there something touching me at this location? And X and Y is our current location, and enemy is what we want to check for. And if there is one, if one exists, then we create a new variable called bits created so far, because we're about to create a bunch of bits. And we set that to 0 because we haven't created any yet, but we're going to. And then we do a while loop, which is a new thing that is just exactly like an if statement, except it keeps repeating until it returns false, until the thing that you're checking is not true. So the thing we're checking is bits created so far, that variable we just created, is that less than this variable called number of bits the player is made of. And that is on the game object. We can middle click that, I think, yeah, to go to the game object, which is the game object is like the universal manager thing we created that's always running, it never gets destroyed, there's only one of it ever, and we can use it to store any information that we want to exist beyond our own death. Sounds overly dramatic, but that's why we had to do it this way, because if we store that information on the player, then when he died, we wouldn't be able to access the information because we destroyed the only player there was. And so the information about how many bits he was made of no longer exists. He's been completely obliterated. So we have to store that on the game object. And we just set that on the create event of the game object. So this is a constant. It's something that's never going to change. We just tell the game what it is as soon as the game starts. So this game object is always there. It's always in the room. So its create event will execute when the game starts. And in that create event, we say number of bits the player is made of is 9. That's the only thing we're talking about right now. So that is established then, it's never going to change. And then when we come to create all the bits that the player should explode into, because we're dying, we've just touched an enemy, that's what we're checking against. We start with 0, and so this says, while 0 is less than 9, do this, okay, 0 is definitely less than 9. And what we do is we create a new bit, and we remember its name, we call it new bit, so that we can access it. We don't actually need to do that, I think. No, we don't anymore. So we could just equally have instance create there, we don't need to store its name. When we first wrote that, we did want to do some stuff with it, but we changed our mind about where that had happened. So we just create a chunk, then we increment this bits created so far variable. We started out as 0, here we set it to 0, but now this loop is going to run multiple times, and each time it's increasing that by 1. So next time it loops around, we'll say, okay, is 1 less than 9? Yeah, it still is. So we'll create another chunk and we'll add 1 to it. Now is 2 less than 9? Yeah, it still is. And so on until we get up to 9, and then it says, is 9 less than 9? No, it isn't. So we stop and we carry on. We stop and we carry on. We stop the while loop, and then we move on to the next bit of code. And the next bit of code is we play a nice explosion sound, and we destroy ourselves. And so that is player death. That is the player dying and creating 9 little chunks that then all fly out in different directions. Now, the code that tells them to fly out in different directions, we moved onto the player chunk object itself. So we have this object called player chunk. Again, I can middle click that to open it. And this is the thing that looks like a little shard of the player. And when it's created, each one, every time you create one, it will run this code. And that code sets a bunch of constants that I'll explain later. And also, I don't know why was I changing something here? I think I was. Yeah, I know what I was doing. I was changing the speeds that things spawn up. Okay, so this bit, I'm actually going to start commenting this as I go through, just so if you miss what I'm saying or you just want an overview, then it will be in the code itself. So this bit is send us flying out at a random speed and direction. And we decided that speed should be randomized a little bit, so it's randomized between 750 pixels a second and 1500 pixels a second. That's a lot, that's moving very fast. And direction is just a random number between 0 and 360, so we've done stuff like that before. And then we also, we're not going to worry about that bit yet, in fact I won't label it yet, I'll come back to that when I come back to it. Let's move this into kind of the order that it becomes relevant. So the first bit, all we care about now is this section, and that just says, send us flying out at a random speed and direction. So, once we do fly out, we want that to happen, we want them to fly out at huge speeds in all these different directions, but we also want them to eventually come to a stop. And by default, a thing in GameMaker doesn't slow down. If you tell it that speed is 600 pixels a second, it will just keep going at that speed forever. So we had to add some code to slow it down, to decelerate it. And I got the maths of this slightly wrong in the video initially. I corrected it in an annotation, but our deceleration value, we want that to be in, so you know we're measuring all our speeds in pixels per second. We're saying like our speed is 300, that means we are moving at 300 pixels every second, and that means it doesn't matter how many steps we do a second, we'll always move the right actual rate in real time. So if you want to do deceleration or acceleration, either of those, they are both rates of change in speed. So speed is distance over time, it's how much distance you travel in a certain amount of time. And acceleration is how much speed you lose over time, or the speed you gain in the case of acceleration. So that means, since speed already has time in it, and we want the change in speed, that means time is a factor twice, basically. You don't need to fully understand that, but just know that when you're talking about, if we want to compensate for the room speed, then on a speed we have to divide by the room speed once. On an acceleration we have to just divide by the room speed twice, because we want to say, if we had a speed of 1500 pixels a second, we would lose that in exactly 1 second with this deceleration. That is what that number means. It means that's how much speed we lose per second. So, don't worry about acceleration for now. We're just talking about how we decelerate. I will change that comment so it says we measure acceleration in speed lost per second. So time factors, or let's say room speed. Let's say room speed factors into it twice. And now, in the end, we want these shards to not just fly out and slow down, we want them to also collapse back in on themselves. And so that means there's kind of two phases to the life of these shards. When they get created, they're flying out, and at some point, once they stop flying out, they're going to shrink back in and reassemble. So we created a variable for that called reassembling, which we set in the create event. And if that's false, then we are still flying out from the initial explosion. So I'll write that here. We're still flying out from the initial explosion. Typing is surprisingly hard when your characters don't appear instantaneously, because you do that thing with, like, you know, if you try and speak when you can't hear your own voice, you start to say the same syllable again and again because you think it hasn't come out yet. That's I tried to type flying twice then. We are still flying out from the initial explosion, and then, so the else part of that if statement is we've stopped flying out and now want to be sucked back in. That's really slow, but like, to be fair, it is having to make characters display on screen. That's a very demanding thing for like a quad-core processor. So yeah, we're focusing on this first section first. This is a section for when we are still flying out of the initial explosion. You can think of it as like the shards have two phases to their life, and this is the first one, when reassembling is still false, which is what we said to initially. And in that section, if our speed is, if we still have some speed, then we want to reduce the speed. And in fact, we always want to reduce that speed until it gets to either 0 or so close to 0 that if we decelerated, we would actually go past 0 and into negative velocities, which we don't want to do. For now, we don't want it to shoot back just yet. We want to decelerate until we stop. And so we could say something like, maybe the intuitive way to do it would be like, if speed is greater than 0, then we want to keep decelerating. But the reason we don't do that is our deceleration could take us past 0. And so we say, if speed is greater than deceleration, then we definitely know we can safely subtract deceleration from that and we still won't hit 0. So there is still some speed to lose, and we want to lose it. So if there's still some speed to lose, then face the direction we're going. It's not strictly necessary every step, but might as well have it in there. And reduce our speed by deceleration. So for now that's 1500. That's 1500 pixels per second per second. We lose 1500 pixels per second of speed every second. And so once we get close, it's actually quite likely that we will have little enough speed. Once we're slowing down, once our speed is almost gone, we will hit a point where our speed is less than 1500 per second. And at that point, we might as well just lose all our speed right now, because that's what our deceleration should do. So this, let's actually put this inside this if statement. So I made that a heading. This is going to be really, really verbose, lots and lots of comments and spacing and stuff, just to make sure it's totally clear what we're doing and why. So if there's still some speed to lose, face the direction I'm going and reduce our speed by deceleration. Now this else is for the situation where there isn't enough speed to lose. Our speed is so low that subtracting deceleration would make it negative. It's like typing when drunk or something, like you can't quite see what you've written because it's too slow. Our speed is so low that subtracting deceleration would make it negative. Our speed is less than deceleration because it's not greater than deceleration. Or it is exactly deceleration, in which case we're going straight to 0, so that's what we want anyway. In fact, just to be completely correct, I'll write that. We'd make it 0 or negative. So, in effect, we are still subtracting from our speed, but we're just subtracting whatever is left. If it's 0, we subtract nothing. If it's half of what deceleration is, we subtract that. But we don't need to know what it is. We just say, first things first, stop completely. We don't want our speed to go negative for now, we just want to stop. Because what we might want to do later actually is have it stop. Like when you explode and the bits will slow down, when they reach the extent of their explosion and they stop, we might want them to stay there for a while. In fact, I think we probably will do that. We'll say, like, after the bits explode, they'll just wait on the ground for a while and then they'll start to reassemble, because then there'll be more of a penalty for dying, and that'd be cool. Stop completely, and then we'll say, get ready to head in the other direction. We'll say opposite direction, because that's what it really is. We stop completely, get ready to head in the opposite direction. That doesn't mean turn around visually, like the sprite we won't see it turn around, we don't want it to turn around. We're just saying, when we do have some speed, it will be in the opposite direction to what we were travelling in just now. And then, how should we describe this? We're setting reassembling to true, so that next time we won't do any of this. All of this is over now. That was the first phase of our life. We're into the second phase of our life, where we are reassembling. So we could say, enter reassembling phase. I'm just explaining what we did last time. There are actually lots of different ways of doing this, and since making the video I kind of thought maybe it would have been better to do it this other way, or there's another simpler way. But I think if I try and explain another way of doing this, it's going to get even more confusing for anyone who's having trouble keeping up. So we're just going to explain exactly what I did, so that you know how it works and that you understand this part. It doesn't matter really which way you do it, so we might as well stick to one and just make sure everyone's on the same page and everyone gets it. I should have mentioned earlier, this was moving much faster than usual, and it was just a very fiddly, somewhat elaborate thing. I thought it was going to be simple, and then when I came to code it, I was like, actually this is a little bit tricky because we've got to set a variable on a third object. So I completely understand why people would have trouble keeping up if they're totally new to this stuff. because it's really like a language, and once you know all the words, when you first learn a word, it's hard to use it in every context, and then once you're really comfortable with them, you start to be able to kind of just speak the language more fluently. And God knows I'm not fluent yet, but certain basic elements of it seem logical to me. Like, oh, we could just set a variable there. Oh, we could just keep the count on that object or whatever. But yeah, I do appreciate that's not going to be easy to follow. So that was the first phase of our life, and we've specified when it is that we stop, that we leave that phase and we go into the reassembling phase. Reassembling equals true. So we've stopped, we've exploded all the way out, and we've stopped there. And now we've set reassembling to true. So now we want to go suck back into where we came from. And we're going to do that at slightly different speed, which is why we have a separate acceleration value here. So let's actually, I'm going to put acceleration at the bottom, because deceleration is the one we use first. And I'll even label these just to be ultra clear. Deceleration is for slowing down. Let's just say is for when we're blowing up, and acceleration is for when we're sucking back in. And we want that to happen slower, just because it's like the explosion should be really big and sudden, and pieces are going to slow down quickly. And then when they pull that together, I want that to be quite a gradual, like, cool effect of them, like trickling across the ground and merging. So in this second phase of our life, we will label it. Oh no, I guess we have labeled it. So that's our label for this. Do it as a kind of heading, just to be clear. And it's not specifically about the speed bit. Increase our speed. And then, so we want to increase our speed because we've stopped completely and now we want some speed. We've already set our direction to be towards where we came from. We could, no, I won't go into alternate ways to do it because it's going to confuse the issue. We've set our direction correctly here, and we are going to accelerate towards it. Every frame that we're in the second phase, we are adding on our acceleration to our speed. So we get faster and faster towards that point. Now, the only other thing we need to do is say, did we get there yet? Are we close enough to our original position that our speed is going to take us past it or to it? So this is just like the bit earlier where we said is speed greater than deceleration. In that case, we were checking we still had enough speed. In this case, we are checking the other way around. We're saying, are we close enough that we don't need to go any further? So this says, if our, I'll write it out, if our distance to our, I'm going to call it birthplace, where we came from, is so small that we're about to reach or go past it. So I'll change that. We haven't technically reached our initial position. We're going to go there. Then stop. Speed equals 0. And now we could. It makes a certain amount of sense to say, oh, let's actually go there. Let's say x equals original x and jump to the exact position we came from. The only reason I don't do that is that our shard is the center of our shard is actually like the fat end of the teardrop shape, and so if we put them all exactly in the same spot, they all had the same origin. They all came from the player's exact location. So if they all went back to the player's exact location, you'd get a kind of like bristly chunk of things all sticking out in different directions. It would probably look okay, but I think it looks a bit better if we have them stop just one step short. So this is the frame when they would have gone all the way to their original position, and we stop them now. We say speed equals 0 now, because we want it to stop with all these shards pointing inwards, and they haven't quite reached their origin, but as you see in the game, they are clustered tightly enough that they make a full player. If it looked wrong, we would tweak it. If we really cared about it being right, we would go in and change the origin of the sprite and do it all precisely, but we don't. Basically, this looks good enough. If they stop just before they get to their destination, it looks okay. I don't think I explained that at all in the video. That was just something that like happened to code it that way and it looked okay, so I rolled with it. So we stop, and then we want to, if we're in position, we want to count ourselves. We want to tell the game object, hey, one more bit has been reassembled. I just got here. I've just arrived. I'm reassembled. Please count me. And then we want to not count ourselves again. So here we say, did we only just arrive? And here we say, yes, we weren't in, let's actually write that as a variable, in position before. So count us as having arrived. So we only just arrived because our in position thing is false. When we're created, that is set to false. And if it's false now, that means we've never arrived here before, because as soon as we do arrive, we set it to true. So remember that we've already been counted. Let's say remember that we are here and have already been counted. So when we first arrive, we count ourselves, we tell the OGame object that there's one more bit that's arrived, and then we say, we are now in position, we remember ourselves, okay, I was counted that time, so don't count me again. And then every step from now on, it's a bit inefficient, but we will, this code will pass this check because we're right next to the origin, and our speed will be 0. We won't need to set it to 0, we'll keep setting it to 0 again and again. And this bit we will fail because our in position variable has been set to true. It's been set to true here. So every future time we will fail this bit and will never be counted again, which is what we want. We only want each piece to be counted once because we want all 9 of them to have to come back before we trigger this next bit. So here, have all of the pieces returned yet. So this is checking, okay, that variable we just changed. We told the game object, hey, the number of bits reassembled has gone up by 1 because I just arrived. And that same frame or in a future frame, every frame from now on basically, we'll keep checking, hey, the bits reassembled, have they gone up to the number of bits that we were made of yet? Because if they have, then it's time to reassemble. There were 9. If I'm the first one, then I'll arrive, I'll increase this bits reassembled from 0 to 1, and I'll set myself to true, set my in position value to true, and I'll never count myself again, and I'll keep checking, hey, have there been 9 yet? Have there been 9 yet? Have there been 9 yet? If I'm the 9th one, then I will do this. I've just arrived, so my in position is false. I'll come to the bits reassembled bit, and I will increase that counter by 1, and I'll make a note that I'm in position, and then I'll do this check again, and I'll say, okay, the bits reassembled, which is 9, is that greater or equal to than the number of bits the player is made of, which is 9? And I'll say, hey, actually it's equal to it. So create the player and destroy all the chunks. So let's make some notes of that. The number of bits that have returned to position is the number of bits that came out of us. That's a nice thing to say. So recreate the player. We'll say destroy all the chunks and reset the count. Reset the bits reassembled count. Put that in inverted commas. This is being overly clear now. It should be incredibly obvious that that's what that is, but we might as well write it out. So in fact, now that I come to explain it, all of this could be inside this check, because this only runs once per bit. And that was important when we're counting them, because we definitely only want to count each one once. And it doesn't really matter whether this is in or out of that. This could be running all the time on every single bit, or it could only be running on each bit as it arrives. When it arrives, it says, okay, am I the last one? And then we run that check. That's maybe a better way to do it. I'll leave it as is for now, because I'm just trying to explain how I did it, not the best way to do it. So yeah, that should be, I think, all of it. So we can just glance back at the create event just to explain, make sure everything in there is something we understand. This is when we're created, remember our original position so we can head back to it. We use that later. And here, initially we are not in the reassembling phase, nor are we in position. We kind of are when we're spawned, we are in the original position, but obviously we don't want to count ourselves as having returned to that position. So we could phrase that better. We could say, nor have we returned to the original position. So we're not in the reassembling phase and we haven't returned. Those are the initial states, and that's why that's how we tell it to go in this first state first, where we're not reassembling and we're just flying out. And I think that's everything. When I was explaining this, I didn't actually annotate it, so I'll say this is the player step event again. This is the bit where we check whether there's an enemy touching us. Look for an enemy touching my position. I'll just say touching us. If there is one, create 9 bits. I mean, arguably you shouldn't put numbers in comments like that, because if you change the 9 later, then it would no longer be true, and comments that are no longer true can be misleading and make you think your code is doing something that it isn't. So let's say create a number of bits. Yeah, that's all that's doing. And then we'll just be super clear and say create a bit, and how to describe this? I mean, we could say increase the count, but that's obvious. Count it as created, and that loops. This loops until enough bits have been created. Okay, an explodey sound, and finally destroy the player. So that's everything annotated now, so I'll upload this as the source code for this episode, and I'll overwrite the previous part 6, so that it's as clear as humanly possible, and I'll just show it in action, just so we can recap what it actually does. And what it does is, if it breaks, that would be so funny, wouldn't it? When you touch the enemy, fly up into loads of little pieces, they all fly back into the same place, and then the player is reformed. So you touch the enemy, creates 9 different fragments, sends them out in random directions, and then each little fragment, it's flying at a very, very great speed, it's decelerating all the time, and once it stops decelerating, it goes into this second phase of its life where it accelerates back towards its original position, and when it reaches its original position, it stops dead, and it counts itself, and once that count reaches 9, we respawn the player. So hopefully that makes sense. I'm sorry that it went a bit too fast in the original episode. That's not going to be like the new pace or anything. That was just with this one thing, turned out to be more fiddly than I thought. So I kind of raced through it because I was like, shit, this is taking a long time. Next thing will probably be simpler than that. We'll be reusing this code for blowing up enemies and stuff. So hopefully that makes sense.